All right, today's lesson is about inverses. And even though I'm not here today, I still expect you to learn it. Inverses, it's actually not that bad because there's 3 different ways you have to know how to find an inverse. The main idea about inverse, though, is you just switch the x and the y. So when it comes to points, I could give you, a specific point like 2, 3, and ask you to tell me what the inverse is. So by the definition, all you have to do is switch the x and the y value. So the inverse point would be 3, 2. So notice we're not changing any signs, we're just changing the order of the x and the y. And that's basically what an inverse is. Now on the test, there's 2 sentences that you have to know, and I'm going to straight up just give you the answer. So just memorize this and you should be good. So here's one of them. If 2 functions are inverses of each other, then the domain of one is the same as the range of the other. So that exact sentence, maybe it's not that exact. It's going to say if 2 functions, f of x and g of x, are inverses of each other, then the domain of f of x is the same as the range of g of x. I just didn't want to write all that. But, I mean, that kind of makes sense because your domain is the x value and your range is the y value. So if you switch them and they're inverses of each other, the domain becomes the range and the range becomes the domain. Along the same lines as points, there's a second question on the test that says if x1, y1 is on f of x, it's going to say blank is on the inverse. So they're just giving you a general term. It's still a point, just like the example up above where we talked about 2, 3. So if x1, y1 is on f of x, then that must mean that y1, x1 is on the inverse. So those 2 exact questions are on the test. I told you guys from the start, I'm going to try to make this as easy as possible. So you just have to memorize those 2. So when it comes to graphs are pretty much done the same way. If you want to graph the inverse, you just need to know some of the numbers that are on the graphs. Some graphs might have points on them, some graphs might not, and you have to put the points on them. There's no rule on how many points you should do, but you should, get a handful. The more you can get, the better your graph will get when you do your inverse. So what I do is I put the original points down so that way I can find the inverse. I want to go in some organized fashion. I just don't want to go off of random points. So I want to go maybe starting from here. This is like the starting spot of this graph. 1, 2, 3, 4 to the left. So it's -4, 0. The next one is left 3 and up 1. And then the last one that they gave us is 0, 3 up. Again, if you really wanted to, you could pull some more points off, and the more points you use, the better your picture will get. So that one right there, if you wanted to use that one, it's 1, 2, 3, 4, 1, 2, 3, 4. So 4, 4. So if we want to graph the inverse, using the definition from up above, all you got to do is switch these guys. So 0, -4, 1, -3, 3, 0, and then 4, 4. So if I was going to graph this, 0, negative 4, 1, 2, 3, 4, 1, negative 3, 3, 0, right here, 3 to the right, and then 4, 4, 1, 2, 3, 4, 1, 2, 3, 4, so it's about right here. So the inverse graph goes like this. Now on the test, I had a bunch of people trying to reflect it across the x-axis or reflect it across the y-axis. There's a reflection, but it's not across any axis. It's across this horizontal line, or not horizontal, diagonal line. So the picture that we have over there, something like this. Right here, right here, right here, right here. So as you go across that blue line, it's the opposite. You notice how the curves are backwards from each other. So that is another thing you can do to try to help you graph, just a little bit better. The next one, same strategy. You just got to find the points, beginning, middle, and end. So I'll start with this one first. That looks like it's at 2, 1, 2, 3, 4. Wait, 1, 2, 3, 4. So 2, 4, and then 1, 2, 3, 0, and then 5, 1. So if I want to graph the inverse, I just have to take those points and switch them. So 4, 2, 0, 3, 1, 5. So it looks like if I was going to graph this, it's 1, 2, 3, 4, and then up 2. Which I don't need that point right there. Right there. And then 0, 3, 1, 2, 3. And then 1, 5. 1, 1, 2, 3, 4, 5. And the reason why you want to just like list them in order is because that's how you connect the dots on these. So first, second, third. So it's like that. The last thing that we have to talk about is how to find the inverse of an equation. Now, even though that definition earlier that we said was to switch the x and the y, that's exactly what we do even with equations. So I'm going to give you 3 versions of the problem. You need to know how to do it in a linear problem. That means there's no exponents. And you also need to know how to do it if there's exponents. So example 1 of actual equations. So let's say we have y equals 3x squared minus 8. If I want to find the inverse, I literally just switch the y and the x. So x, y, and then everything else stays exactly where it's at. So the 3 stays in front, the 2 goes up here, and minus 8 goes here. Now the last step to this is to get y by itself. So to get the y by itself, we would have to add 8 to both sides. So these cross out, so you have x plus 8 equals 3y squared. And then you have to divide by 3, so divide the whole thing by 3. So you have y squared equals x plus 8 over 3. And then the last step is to square root both sides. So you end up with y equals plus or minus square root of x plus 8 all over 3. Now, because it's an inverse, we want to say that it's a little different from the original, so we put a little mark on it like that. So that would be our answer. Let me give you a linear one. Example 2, y equals 3x plus 5. So if I was doing a linear example, same rules as before, switch x and y. So x equals 3y plus 5. Then we want to get the y by itself. So I would subtract 5. So I have x minus 5 equals 3y. Then just divide everything by 3. So I have y equals x minus 5 all over 3. And then we just put the little -1 to show that it's not the original problem. I'll go ahead and just do one more. Example 3. I'll do one that has a radical on it. So let's say y equals radical x plus 2 minus 4. Switch x and y. So x equals radical y plus 2 minus 4. Now, when you guys are working with radicals and you're trying to solve for that y that's inside of there, you have to isolate the radical first. So that means we don't want anything outside the radical. So the first thing we have to do is add 4 to both sides. So we have, oops, that's gone. We have radical y plus 2 left over, and then x plus 4. So now we want to get the radical to disappear. So the opposite of a radical is raising it to the second power. So we do that to both sides, so the radical and the square disappear. So you have y plus 2 equals x plus 4 squared. Now x plus 4 squared means x plus 4 times x plus 4, but we actually don't have to simplify that. We could just leave it. We don't have to FOIL it. And then we want to get y by itself, so we just subtract the 2. So we end up with x plus 4 squared minus 2 equals y, and then we just put the little -1 to show it is not the original equation anymore. So the lesson today is about inverses. If you have points, you have to switch the x and the y. If you have a graph, you have to get the points, switch the x and the y. And then if you have an equation, you have to switch the x and the y and solve for y. Now for your practice is actually going to come off of 2 different pages because I want it to be very similar to what you'll see on the test. So your assignment for today comes from 0.4. You'll do numbers 1 through 6. And then you will also do from 0.5. This is going to be, let's see. I'm going to also give you a couple of review questions. So let's do, let's see. Let's do 5 through 8. Do I want to do 5 through 8? Yeah. Let's do 5 through 8. Actually, let's just do 5 through 10 on that second page. 5 through 10. And if you guys have questions on the assignment, the answer key is posted on the wall. So don't just jot nonsense down. Try it. Go check your answer on the wall. Make sure you're practicing right. You can practice till you're blue in the face, but if you're practicing wrong, you're still going to fail the test. So it's real important that you're trying to actually get the answer right. If you have questions, you can see Mr. Rest in the Cardinals Nest or Mr. Segovia. I'm off campus, so I won't be here, and I have a game after school, so I won't be here until about 9 o'clock at night. If you still have issues or questions on the assignment, you can come by in the morning. I get here usually around 7 to 7:15. I'm not asking you to show up that early, but I mean, if you really want to pass the class, show up, 7:40, 7:45. Get your couple questions answered each day, and you'll be good. See you guys when I get back.